Jain to all, I am Samender Singh, Assistant Professor in the Department of Computer Science and Engineering. My college name is Ajay Kumar Garg, Engineering College, Ghaziabad. Today I have a session. My topic is gradient descent. It is a very complex topic as far as as far as we deal with artificial intelligence. Let us start. Our course outlines are: first, I will discuss some numerical on convex optimization. After that, the main topic, that is gradient descent. We will start with definition. Then we will discuss some problem related to gradient descent. After that, a cost function. We will discuss what is cost function. And in the last, we will discuss some advantage and disadvantage of gradient descent and types of gradient descent. This is all about my course outlines in today's session. Let's discuss the first numericals on convex optimization. First, that is production planning problem. Let's see what is the problem. A company produces two products, X and Y, means these are two products. The profit per unit for X is $10 and for Y is $15. Product X requires 2 units of resource A and unit 1 of resource B, while product Y requires 1 unit of resource A and 2 units of resource B. The company has 100 units of resource A and 19 units of resource B available. Determine how many units of each product the company should produce to maximize product profit. So you can see here number of constants are given. So we need linear programming to solve it, or we can say we are using convex optimization. So to formulate the production planning problem as a linear programming problem, we need to define certain things. First, what is decision variable? After that, objective function. And in the last, we need to find all constant of the given problem. As we can see, there are number of constants while reading this problem. So starting to find the decision variable, we have two main variables, that is X and Y, or we can say these are two products of the given problem. So X, what is X? Number of units of product X produced, and Y is the number of units of product Y produced. So these are the number of each products. These are our decision variables. So we can find first thing. Now second thing is finding what is objective function. So objective is to maximize profit. When we concern profit, it must be maximized, which is given by the total revenue minus the total cost. This is very simple thing. The profit per unit for X is $10 and Y is $15. This is mentioned in our problem. Therefore, the total profit Z can be expressed as this one: 10 unit of X, 15 unit of Y. So this is our entire profit Z. So this is objective function. This is second thing that we need to find. Now last thing is constant. What are constant? Let's see. Resource A constant. Product X require 2 units of resource A and product Y require 1 unit of resource A. The company has 100 units of resource A available. Therefore, the entire equation will be 2x plus y, that always remain less than or equal to 100. So this is our first constant. Now this is our next constant condition, that is resource B constant. Product X require 1 unit of resource B and product Y require 2 units of resource B. The company has 90 units of resource B available. Therefore, This is second equation, or we can say second constant of our problem. So two conditions, two constant. This is our requirement. Now we know a general fact, that is non-negativity constant. That means the number of unit produced cannot be negative. So we need to find two general constant, that is x always greater than or equal to 0. In the same manner, y is also greater than and equal to 0. So this is our formulation of the given problem. That is, we need to maximize the function, that is z equal to 10x plus 15y, or we can say profit is always maximized. So this is our first thing. Then second, these are the number of constant. First constant, first condition, that is 2x plus y less than or equal to 100. And in the second constant, we have x plus 2y is always less than or equal to 90. And these are two general constant, that is x and y both must be greater than or equal to 0, since these are the non-negativity constant. So this is how we formulate the given problem. Now let's see the second problem, that is investment portfolio problem. It is very important as far as our examination concerned. Let's see what is problem. An investor has $50,000 to invest in two types of securities, that is stock A and stock B. The expected return per dollar is invested in stock A is, what is this? $0.08, and in stock B is $0.12. Due to risk consideration, the investor decide to limit investment in stock A to no more than twice the amount invested in stock B. Determine how much money the investor should invest in each stock to maximize the total expected return. So again, here we have to concern with our profit. So we need to maximize our profit. Let's formulate it. Again, we need to find three things. First, decision variable, then function, or we can say objective function, and after that we need to find what are the constant. Let's start. There are two decision variable. First is x and y. What is x? Amount of money invested in stock A. Definitely it will be in dollars, in the same amount of money invested in B. So stock A represented by x and stock B represented by y. These are our two decision variables. Now next thing is to find the objective function. The objective is to maximize the total expected return, profit. The expected return per dollar invested in stock A is what? $0.08, and in stock B it is $0.12. The total expected Z, or we can say profit, will be this one. This is our function, that is Z equal to 0.08x plus 0.12y. Next, what are the constants? So here number of constants are given. Let's start. The investor has $50,000 to invest. Therefore, the investment constant can be written as this one. X plus y is always less than or equal to 15,000. And second is this constant. What is this constant? The investor decide to limit investment in stock A to no more than twice the amount invested in stock B. So X always less than or equal to twice the Y. This is second constant, which is known as risk constant. Now again, general constant, these are the non-negativity constant. This is the amount invested cannot negative. So these are our two general non-negativity constant. So this is how we formulate the given problem. Number one is function, then risk constant, and this is the third. So in our problem, three constants are there given. X is less than or equal to 2y, and the second are x is always greater than x and y both are always greater than equal to 0. So this is how we formulate the given problem. There are 4 equations. First function, objective function we can say, and 3 constant. Now this is our second topic, that is gradient descent. Till now we have optimized the problem in which we have constraint. Now new topic is start, where we didn't have any constraint. So most popular algo is gradient descent. What is this? It is a method for unconstrained mathematical optimization. So we have general problems in which no constant are given. So optimize that problem. We have a very, very good problem. We have very, very good algorithm, which is gradient descent. It is very, very important as far as our syllabus concerned. Let's elaborate it. It is a first order iterative algorithm. Means we have number of iterations there. For finding a local minimum of a differentiable multivariate function. Here 2 things are. First is minimum and second we are differentiable multivariate. Minimum means we are going to find the minimum point, global minimum point of the function. First thing, your first target, and second is what? Of a differentiable multivariate function. Means we have number of variables that has to differentiate. The idea is to take repeated step in the opposite direction of gradient of the function at the current point, because this is the direction of steepest descent. We will discuss later. Stepping in the direction of the gradient will lead to a local maximum of that function. The procedure is known as gradient ascent. These 2 things we will discuss later in our session. Gradient descent is generally attributed to, who is the inventor? Who is the person who invented? This is Augustin Louis Cauchy, who first suggested in 1847. After that, we have number of persons who do work of that particular term. In mathematical terminology, optimization algorithm refers to the task of minimizing and maximizing. When we talk about optimization, both comes, either minimizing the things and maximizing the things. Minimizing where cost should be minimum, maximize means profit must be maximized. An objective function, suppose it is fx, parameterized by x, it is our parameter. Similarly, in machine learning, optimization is the task of minimizing the cost function parameterized by the model's parameters. The main objective of gradient descent is to minimize the convex function using iterations of parameter updated. Once these machine learning models are optimized, these models can be used as powerful tools for artificial intelligence and various computer science applications. If we move towards a negative gradient or away from the gradient of the function at the current point, it will give the local minimum of that function. Whenever we move towards a positive gradient or towards the gradient of the function at the current point, we will get the local maximum of the function. Here repeatedly we have one word, that is gradient. What is gradient? Suppose we have a function fx. We can say fx is x square. Let's see the graph of this one. This is x-axis, this is y-axis. Graph must be this one. Now we need to find the minimum or maximum, both point is there. But by means of gradient optimization, yeah, gradient descent, we always find minimum point. So where it must be there. By seeing this graph, we can easily find where our minimum point is. But as a mathematical, how difficult is to find. So what are the steps? First, we need to find the gradient. Gradient means this derivation of our function. Derivation of our function. Since it having one variable, it is easy to find the derivation. That is df upon dx. Suppose our function have more than one variable. So this one. Again, we want to find the minimum function. So procedure will be same. We need to differentiate it with respect to all parameters, yeah, all variables. The differentiation of the function with respect to all parameters are known to be gradient. That means df upon dx and df upon dy. So this is known as gradient. I hope you will understand what is the meaning of gradient. Or we can say, suppose we will start at a random point. This is our random point, point 1. So to find the gradient of this point, we need to differentiate this function with respect to given parameter. So parameters is x. So the df upon dx will be, what is this? 2x. Suppose this is our point. Suppose this is -1. So at this point, what is the value of gradient? That is 2x at x is equal to -1. That is 2 into -1. It will be around -2. So this is our first minimum regarding, or we can say at a random point. This is thing. Now at point this P1, we have two directions, either to move upward or downward. Clearly it can see if we move upward direction, we will find the maximum value. But through this gradient descent method, we always find minimum. So we need to find we need to move in low direction, or we can say down direction. So in every step, what we will do, the direction is always concerned. So these 2 points highlight these things. If we move in negative gradient, means to this depth, always less than the previous value. So we will get the local minimum. Every time our gradient must be less than the previous gradient. So we will move in down direction, and hence we can collect, or we can find the minimum value. In the same way, if we want to find the local maximum, so in which direction we have to move? In the opposite direction of that one. That is towards upward direction. In that point, we will move towards a positive gradient. Means always gradient's value will increase. So at this point, our gradient is what? -2. If we find value that have value less than this one, suppose if we have -5, -6, or value less than this one, So that means we are in the right way to find the minimum value. Graph wise we can see this is our first point, initial weight, initial value. Again, this is our tangent, or we can say df upon dx, gradient incremental step. Gradient descent always find the minimum value, so we have to move in this direction. Next will be this one, then this one, then this one, then this one, and last we will find the minimum cost, or we can say minimum value. So this is derivative of the cost to down direction. Next gradient must be less than the previous one. This is how we can find. Let's see, the entire procedure is known as gradient ascent, which is also known as steepest descent. The main objective of using a gradient descent algorithm is to minimize the cost function using iteration. We need number of iteration to achieve minimum point. To achieve this goal, it performs two steps iteratively. First step is calculate the first order derivative of the function. It compute the gradient of the or slope of the function. That is, if our function is fx, that means we need to find the df upon dx. This is our first step. Move away from the direction of gradient, which means slope increases from the current point by alpha times. Where alpha is defined as learning rate, it is a tuning parameter in the optimization process, which has to decide the length of the step. Next thing is what is cost function. The cost function is defined as the measurement of difference of error between actual value and expected values at the current position and present in the form of a single real number. It helps to increase and improve machine learning efficiency by providing feedback to this model so that it can minimize error and find the local or global minimum. It continuously iterate along the direction of the negative gradient until the cost function approaches zero. At this steepest descent point, the model will stop learning further. The cost function is calculated after making a hypothesis with initial parameter and modifying these parameters using gradient descent algorithm over known data to reduce the cost function. So what is cost function here? I already told you, to find minimum value, we need to find gradient. So suppose at initial point gradient is, we have G1 gradient at initial point. At initial point. This is G1. Now we need to find gradient at lower level. We can say this is our P1 point. Suppose we have P2 point where we find G2. That is gradient with respect to this point. It must be less than this one. If this is, that means we are in the right move. The difference of these two, that is G2 minus G1. What is this? This is our cost function. This is the difference of gradient by moving in lower direction. So at every point, or we can say at every new point, we have a gradient value, and that value by taking the difference of these two gradients, we have a function that is known as cost function. It is. How does gradient descent work? Let's find out the slope of the line from linear regression. The equation of simple linear regression is given that this one. You already told it. in the lower class. What is line has an equation that is y is equal to mx plus c, where y is the y coordinate and x is the x coordinate. This is vertical line, this is horizontal line. And here is two constant. First is m. M is what? It is the slope of the line. And c represent the intercept on the y-axis. So this one. Let's start with our gradient descent with this point. This is our first. So first step is we need to find the gradient at this point. And then next point, suppose this is P1 point, this is P2 point, this is P3 point, this is P4 point. The direction is downward. Means every time gradient will decrease. So initial point will give gradient G1, then G2. Then we will take the difference of these two, that is G2 minus G1. In the same manner, we have to achieve this one. When this difference will minimum, or we can say zero, that means our goal is achieved. This function will continue until when the difference is approaches to zero. Now you can easily understand how this step is going to iterate. We will iterate it until the difference will approaches to zero. This is how gradient descent works. You can easily. Point of convergence, that is where the cost function is at minimum, or we can say approaches to zero. When this happens, that means our goal is achieved. So this is enough for today's session. Next time we will do some related.